Hai, Assalamualaikum and selamat malam everyone. Okay, so we continue revision Form 4 Physics online class. Part 4. So tonight we discuss about chapter 5 waves. Okay, before that let's look at some important points that you need to know for this chapter 5. Speed revision. Okay, for the first part, it's about fundamental waves, where you are introduced to important points, important terms. Something like amplitude, period, frequency, okay. There's some formula. Period, amplitude is maximum displacement. From equilibrium point. Period, time taken for one complete oscillation. Frequency, number of complete oscillation in 1 second. Speed, distance traveled per unit time. Okay, so we have this one. From formula of speed equals to s divided by t. Okay, an object like this graph, st graph or dt graph, distance against time. Distance traveled for one complete wave is lambda. The time taken is period. So distance traveled lambda, time taken is period. Lambda time period. What is this 1 over period is frequency. So lambda times frequency. So we get this formula, or normally written as V equals to F lambda. So the speed of wave can be calculated as the product of frequency and wavelength. Okay. And then another important terms like wavelength, wavefront. Okay, you must understand. You must know the definition. Okay, like wavelength, distance between two adjacent crests or two adjacent troughs, wavelength, or distance between two consecutive points which are in phase. Okay, wavefront is a line that joins all points which are in phase. So I think you are all introduced to important terms, okay, for waves. So that later when we discuss the question, you will you know what I mentioned about. The question is about what. So you must know all the important terms in this topic. Wait. Okay, and then you are also introduced to type of waves. Okay, so progressive wave, progressive and stationary wave. Okay, type of wave. Progressive wave profile move along with the motion of the wave. stationary wave profile does not the stationary wave we just discussed until here only, the definition, what is meant by stationary wave. So progressive wave continue. So we have trans Okay, sorry at the line interruption. So we continue. Okay, discussion on the chapter 5 waves. Okay, we'll look at question number 1 for paper 1. First, requires a medium to transfer energy. Second, made up of vibrating particle. Third, seismic waves on the surface of Earth, sound wave, water wave. The above statement describe the characteristic of. Okay, if you put it as A, electromagnetic wave does not require medium to travel. B, mechanical waves. This is of course like water waves, sound wave, or mechanical waves. Stationary waves does not explain this one because stationary waves, the wave part profile does not move together with the wave. So the answer should be B. Okay, mechanical is like all the one that require medium. Water wave, sound wave, okay, means require medium. Okay. Okay, number 2, diagram 1 shows electromagnetic spectrum, which is correct for X, Y, and Z. Okay, so you need to memorize the arrangement, kena ingat lah. Okay, so gamma ray followed by X-ray. Okay, and then ultraviolet, and then visible light, infrared, microwave, then radio wave. Okay, so correct arrangement, X must be X-ray, ultraviolet, and microwave. Yes, we get the answer is A. Okay. Okay, number 3, diagram 1 shows displacement time graph of a swinging system. What is the name of the process and what happens to its amplitude? Okay, what is amplitude? Amplitude is measured by this maximum displacement. So here is maximum displacement, okay, this is amplitude. So you can see from 0, the value of amplitude decreases. So amplitude decreases with time, we call it damping. Okay, so look at the answer. Damping, amplitude decreases. Okay, so you have the answer should be A. Okay, process damping, amplitude decrease. Okay, number 4, diagram 2 shows pattern of diffraction when wave passing through a gap. So this is size of gap A. Which statement is correct about characteristic of wave? If the wave that diffracted here curve diffracted wave, means spread more. Say effect of diffraction is more obvious. How to get effect of diffraction more obvious? The size of lambda must be larger or equals to size of gap. So this one you will get effect of diffraction. More obvious. Okay. Which statement is correct about characteristic of the wave? When the wave spread more, the amplitude decreases. So the first part A is wrong. Diffraction happens when frequency of wave increase. Frequency does not affect. Oh yeah, wait, check. Relationship between F and lambda. Okay, if you want the diffraction happens or effect is more, lambda should be larger, means frequency is smaller. Okay, so cannot be. Okay, next C, speed does not change because wave propagates in the same medium. Correct, huh? No change in depth. Okay, so the answer should be C. Number 5, in the patterns of interference of wave, which of following statement is likely to cause distance between two adjacent antinodes decreasing? So this one is already interference. Distance between two adjacent antinodal line is x. D lambda divided by E. Okay, so this is the formula. Okay, if discussed about this type of question, you go and check the formula. To decrease x, either you decrease D, you decrease lambda, or you increase A. Because x and D and lambda is directly proportional, x and A is inversely proportional. So you can decrease x by decreasing wavelength. Decrease distance or separation. No, you should increase it. Okay. Increase the distance between screen and coherent sources. No, you should decrease it because you want to decrease x. Okay, so the answer, the best one is A. The correct one is A. Okay. Okay, number 6. Figure 3 shows phenomenon where seawater waves are heading towards the Cape area. Which of following application uses the same phenomenon? This one is refraction. Refraction of A. What is this? Wave can be spread, okay, behind an obstacle. So this is diffraction. Okay, this one using ultrasound wave. Transmit the sound wave and it reflect back. Okay, reflect. So ini reflection. Okay. And then C, okay, transmit ultrasound wave and then to the shoal of fish and then reflect back. Okay, ini juga ialah reflection. Okay, D, during night time, sound is heard louder. Okay, at night. So this one is refraction of sound. Refraction of sound wave. Okay, so for this question, the answer should be D, donkey. Okay, number 7. Diagram shows a climber screaming in a ravine. He found that his screams were heard again within 4 seconds. So means ini ialah echo. The sound that he can hear back is echo or caused by reflection of sound wave. Okay. If the velocity of sound wave is 340 meter per second, what is distance x? Okay, given 4 seconds. Okay, the moment the the climber scream, okay, at that moment record the time already. Okay, so means the sound wave travel to and fro in 4 seconds. Okay, and then x is only one direction. So to determine x using this formula, g equals vt divided by 2. Why there is divide by 2? Because d one way, the time taken is for 2 way. So that 4 seconds you need to divide 2. Okay, so 340 times 4 divided by 2. So you get 680 meter. Let's check again the answer. Okay, that one is for number 7. Okay, number 8. Diagram 5 shows wave propagate through 3 regions STU. If the wave speed in region U is 8, what is wave speed in region T? Okay, just look at U and T. Okay, remember, distance between 2 adjacent troughs is equals to lambda. So this one also is lambda. So for U, we can put as lambda 1. For T, we can put as lambda T. Okay, given U, V1, the speed in U is V1, so just put V1 8, lambda 70, or you convert to meter, and then you want to find V2. Okay, lambda 2, 12 cm. If you don't change the unit also can, because we are going to use ratio, so later it will be cancelled, the unit. If you want to change also can. Okay, so for this one, refraction of water wave V equals to F lambda. So the wave travel in U and T, same frequency. So F constant. So we get V directly proportional to lambda. So when V directly proportional to lambda, if you take the ratio of V over lambda, you get a constant. Okay, or we can say V over lambda, V1 over lambda 1 equals to V2 over lambda 2. The ratio is constant. Okay, use this formula to calculate. Okay, V1 is 8 divided by 17 equals to divide by 12. Okay, so you solve for this one, you will get V2 in unit meter per second. So what is the correct answer for this one? 5.6 meter per second. Okay, so use this calculation, very simple calculation using formula. Okay, number 9, diagram 6 shows wavefront that move towards the beach from the sea. It observed that the wavefront changes when approaching the beach. So you can see this, the shape of the wavefront actually follow the shape of the shore. Which of following statement correctly describe the situation? Okay, so this is refraction. So we use a formula V equals to F lambda. Okay, so F constant, V directly proportional to lambda. Okay, so the first one should be wrong. Speed of wave decrease when depth decrease, correct. Energy of wave decrease when passing through an obstacle. Passing through an obstacle, what is this? Waves are reflected in opposite direction, is correct. Okay, not necessarily opposite, sometimes in another direction, in another angle, maybe not really accurate. Change direction but not opposite. So maybe certain case is opposite but not all cases. So this is not involving reflection, it's refraction. Okay. So kita tak ada case yang berkaitan. Diagram itu ialah refraction. So change in speed saja. Okay. Number 10, electromagnetic wave spectrum. What conclusion can be drawn based on diagram 7? So from here you can see the wavelength, okay, decrease from radio to gamma, frequency increase. Okay, look at what conclusion can be drawn. Okay, sorry ada interruption sikit. Okay, what conclusion can be drawn based on diagram 7? Wavelength does not change, of course not. You can see obviously from here, boleh nampak jelas ini kan. Distance between two crests ni, ini lambda. Okay, so lambda decrease, wavelength decrease kan. Okay, frequency increase. The wavelength does not affect frequency, wrong, because as we know, frequency and wavelength is inversely proportional. The wavelength is directly proportional to frequency, also wrong. The wavelength inversely proportional to frequency. Okay, so the answer is D, donkey. Okay, that one is paper 1. Just a few questions. You must go and do more paper 1 question. Okay, paper 2, section A, number 1. Diagram 1 below shows a speaker vibrate and producing sound wave in the air. So you can see for sound wave travel, when sound travel, it will cause air molecule to experience compression and rarefaction. So you can see the molecule are closer. So we can say this one is compression, 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 compression. And then we have here rarefaction, 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 rarefaction. Okay. Okay, sound wave. Pick the correct answer. Okay, sound waves are longitudinal wave. Okay, how it travel? Vibration of molecule parallel to direction of waves. Okay. Okay, based on diagram 1, name the area X. Just now already label X compression region. Just write down compression region. Okay. Okay, part 2, mark a distance in diagram 1 with symbol lambda corresponding to one wavelength of sound wave. Okay, so you all boleh tandakan compression and compression as lambda, or rarefaction and rarefaction also is lambda. You can take center to center, center to center. Yeah. Nanti you all tak nampak pula. Just take center to center. Okay, so both can. Rarefaction to center of rarefaction or compression to compression. Okay, so wavelength of sound wave can be defined as distance between two adjacent compression region or two adjacent rarefaction region. Itu definition untuk wavelength of sound wave. Mana? C. If the sound frequency in diagram 1 is increased, what happens to the speed of sound wave? B equals to F lambda. Okay, does the speed will be affected by frequency? What are the factors that affect speed of sound? Speed of sound depends on sound factor. density of medium. Okay, the temperature. Okay, density we can discuss in terms of its mass of molecule and also arrangement of molecule. Okay, state of matter, okay, solid, liquid or gas. Okay, so these are the example. So if sound frequency increase, it just affect the wavelength, not the speed. So what happened to the speed? The speed remains unchanged. Speed remains no change. Okay, the only that change is wavelength. Wavelength sahaja yang change. Speed, kalau you mention change in the medium, okay, factor that affect density of medium like temperature, arrangement of molecule, mass of molecule, then only the speed will change. Okay. Number 8. Should be not number 8, should be number 2, right? Okay. Diagram 2 shows a submarine emitting ultrasonic wave towards the bottom of an island. What is this ultrasonic wave? Actually, high frequency sound wave. High frequency sound wave. Frequency is 20,000 hertz. Very high frequency, or we call it ultrasound. Okay, so ultrasonic using ultrasound. Okay, so ultrasound will be emitted and then hit the hard surface here, reflected and received back by the submarine. Okay, so question A1, what is the wave phenomena involved in diagram 2? So you can write as reflection of wave ataupun just reflection. Okay. Part 2, calculate distance of submarine to the bottom of island if a reflected sound wave is detected after 4 seconds. Detected 4 seconds means moving to and fro. Okay. Okay. The submarine. Okay. The seabed. Okay. The island. The seabed. This is distance D. Okay. Wave trunk. Wave 4 seconds. So D is for one way, thus divide by 2. So 1560, 4 divide by 2. Okay. So you will have the answer will be 3120 meter. Okay, correct substitution. Final answer unit. Okay. The formula, if not given in the list of formula, this one you will get 1 mark. That's why always write the formula. Okay, always write the formula. Formula 1 mark, substitution 1 mark, final answer plus unit 1 mark. Correct unit. 3 markah. Okay, kalau dah ada dalam list, you tak dapat lah markah ni. Tapi biasakan tulis. Okay, part B, table shows 4 different hall characteristic PQRS. Okay, characteristic or aspect discussed here is wall surface and distance between two speakers. Okay, wall surface even, uneven. Distance of speakers far or close. Okay, you have been tasked to find the most suitable hall to hold a charity concert in your area. So, which one you should choose? Actually, we want to reduce effect of sound due to reflection, because reflection will cause noise, okay, or the sound will become not clear. Okay, so wall surface, to reduce reflection, we cannot use even surface or smooth surface. We will choose uneven surface. So reflection occur, it will not occur direct, it will occur in different direction. Okay, means it will reflect it in many direction, not straight to the center of the wall. Okay, something like that. Distance between speakers, this one we choose the, look at x equals to d lambda over 8. Okay, to produce loud and clear sound, we want to produce more constructive interference. More constructive means x is smaller. So how to reduce x? Increase distance between two speakers. A is distance between two speakers. So we should choose 4. So I don't want even, I will choose uneven. I want 4, I don't want 3. So from here I can see Q is the best one, all Q. Okay. So first, the wall of the surface is uneven. Okay. Sound reflected in many directions, not just focus to one direction only. Many directions, so at least we can reduce the reflection of sound. Okay, second, distance between two speakers should be 4. Okay, to produce more constructive images. Okay, or to produce smaller distance between antinodes. Okay, to constructive interference. Okay, nampak tak? Ini soalan. More constructive means more loud sound lah. Loud sound is produced in the hall. Based on your answer, determine the most suitable. So the most suitable is Q. Okay. Okay, look at section B. Diagram 3 shows a person communicating using a mobile phone. What is definition of electromagnetic wave? Wave that consists of magnetic field and electric field that vibrates perpendicular to each other. Okay, so waves that consist of magnetic field and electric field that vibrates perpendicular to each other. This, if this one vertical one let's say the electric field, it will have the horizontal part. Not very okay. So the horizontal part is magnetic field, magnetic field. So when wave travel, this electric field and magnetic field is vibrate perpendicular to each other. One vertical, one horizontal, something like that. Okay, so this one is electromagnetic waves. Okay, part 2, you are required to investigate characteristic of transmitter station as in table 4. Okay, dia punya aspect, frequency, velocity, transmitter, and type of wave. Ini position, ini translation adalah sama. Position of transmitter. Okay. So we just go through the frequency. Okay, now before that, let's look at the whole question first. Explain suitability for each of each transmitting station for transmit signal to mobile phone. Determine the most suitable transmitting station to be used safely to get clear signal on mobile phone. Give reason of your choice. Okay. Okay, first let's look at the frequency. Transmit from the station, we don't want the energy to be lost along the way, not easily lost. Okay, and also it able to travel longer distance, so we need high frequency wave, not low, because high frequency, high energy. So I don't want low, I will remove the one which is low. I choose high. Okay. And then velocity also must be high so that it travel faster. I will remove the one which is lower. I just choose two which is higher. So I remove this one. Same as speed of light. That one is the highest speed or velocity. Position of transmitter must put at high place. So I will reduce the one which is low. I will choose the one high. And then type of waves should be electromagnetic wave because it can travel in vacuum. Sound wave cannot. Microwaves. Let's put complete microwave. What is micro? Okay, microwaves. Okay. Okay, so I can see from here the most thick, okay, obtained by Q. So I will just explain Q. Okay. Frequency high, speed high, position of transmitter high, type of wave microwave. Okay. Okay, you can write in table form. This one is section D. Okay, I want to use this one. Ya, hi Wong Sen Chen. Dan cikgu tak nampak you. Okay, so we can write the answer in this table form. Okay, the first aspect that we need to include is that frequency of wave, velocity of wave, position of transmitter, and type of wave. Okay, you write down the aspect dulu. Supaya tak terlupa. Velocity of wave, position of transmitter, type of wave. Okay, now we add in the characteristic. Frequency of wave must be high or higher. Velocity of wave must be higher. Position of the high place. Type of wave, microwave. Okay. Reason, frequency of wave higher, so high energy of wave can travel further. Boleh bergerak lebih jauh lah. Velocity of wave higher, the signals is transmitted. Okay, signal hantar lebih cepat lah sebab dia laju kan. Okay. Position of transmitter, high place, because less obstacle. Okay, microwaves can travel in vacuum. Okay, if you want to write can travel further distance of second. Okay, boleh. So from here, what is your choice? Q is chosen. Reason, because high frequency, tulis balik yang sebelah kiri. Okay, high velocity, high position transmitter, and use electromagnetic wave ataupun use microwave. Okay, so this is the complete. Okay, as usual, aspect here cannot repeat, but reason can repeat if suitable. Okay, so you get 10 marks for this one. Okay, ada soalan dia tanya. Just continue. Okay, part D. Figure 5 shows microwave oven. Explain how food can be heated in oven. 4 marks. Knowledge question. This is microwave oven, not in the oven only. Microwave oven. So microwave oven using microwave. So the first part, turn on the oven and microwave is transmitted out microwave molecules in the food to vibrate at high frequency. Heat energy, sorry, high energy, large amount, large amount of heat released out and cook the food. Okay. Turn on the oven and microwave is transmitted. Microwave cause molecules of water in the food to vibrate at high frequency. Large amount of heat released out and cook the food. Okay, so this is how food is cooked by using microwave oven, right? 4 marks. Part E, microwave has a wavelength of 3 times 10 to the power of negative 2 meter. The speed of an electromagnetic wave in vacuum given, calculate frequency. So it's very direct question. Huh? Using the formula V equals to F lambda. So you will have F equals to C divided by lambda, because this one is the microwave. Huh? So F equals to 3 times 10 power 8 divided by 3 times 10 power negative 2. You have 1 times 10 power 10 hertz. Okay, so unit kena betul lah. Hertz unit. Part 2, when this microwave propagates in water, what will happen to the frequency, wavelength and speed of microwave? Okay, remember electromagnetic waves always travel at a speed of 3 times 10 power 8, okay, meter per second. The formula C equals to F lambda. Okay, if we apply the same concept of waves, okay, okay, section C, figure 11.1, 11.2 show a red light source that produces interference pattern by two different Young double slit. Okay, for Young double slit, the separation between two slit A. And then the distance between two bright fringes, this is X. Okay. By using diagram 1.2, compare distance between two slits in Young double slit. Okay, you can see in diagram 1.1, the distance or separation is shorter than 1.2. Okay, distance between two slits. So distance between two slits in 1.1 is shorter than in 1.2. Compare distance between two consecutive bright edges x. Longer, shorter. Okay. Distance between bright edges x is longer than 1.2. But 3. Compare distance between screen and young double slit. Okay. G. Same. Okay. Distance between and slit D in 1.1 is equal to in 1.2 or same. It's okay. Relate between distance two consecutive edges x and separation distance between two slit A, x and A. The first one is A, right? So you nampak dari atas 1.1, 1.1. Okay. In 1.1, I miss out again. Okay. So shorter, longer. Shorter, longer. So you can write the shorter the value of x, the value of x, because a and x already defined, so I just write like this. If you want to write fully also can, like the shorter the distance between two slits, the longer the distance between two consecutive bright fringes. Okay, same thing. Name the phenomena involved. This one is interference of markah. Jangan tulis di sini ya, tulis dalam space yang diberikan. Dalam ruang jawapan ataupun helaian tambahan yang diberikan. Saya tulis sini sebab senang nak refer. Okay, part C, diagram 1.3 shows the water wave interference pattern produced by two coherent sources. So what is the meaning of coherent? Produce same frequency, constant phase difference. Sama lah tu. So kita ada ini bright and dark region. The wave pattern is formed caused by superposition of waves, or we call it interference, from coherent source. What coherent sources mean? The sources waves at same frequency and constant phase difference. Okay. Explain how light and dark bands are formed on the screen of the ripple tank. So this is the bright one is caused by constructive interference. Sorry, constructive and destructive. Okay. So the bright and dark actually is caused by light that pass through surface of water. If constructive pass through constructive, it become very bright. Pass through destructive is dark, something like that. So the formation of the bright and dark we can explain using the concept of light passes through the surface which is high amplitude, the shape is convex, okay. Uh, okay, when passes through the one which is destructive, so kita akan dapat dia adalah dark fringes. So boleh apply gunakan, you all boleh draw juga diagram. This is through okay, convex shape converge, so dapat bright. Okay, trough adalah dark. Okay. Okay, so you explain using that one. Add like convex light passes crest will be converge and line or bends trough acts like a concave lens light passes okay, padam dulu ya. Light passes tulisan saya pun dah will be diverge and produce dark. Okay. So kita ada 4 mata. So first you explain they act like convex, light converge, produce bright, and then trough like concave, diverge. Okay, so 4 marks untuk soalan ni. Okay, you want to draw also can. Okay, part D, you are asked to suggest a new port location as shown, a retaining port. A retaining wall. Okay, should be also built at the port. Retaining wall. Okay, that ship, to ensure that ship at anchor are safe from big waves. Okay, you can see there's a gap there. There is a wall here, retaining wall. Using appropriate concepts suggests a suitable port location and modification to prevent erosion. Your answer should include following aspect: port location, retaining port, the surface of retaining port, height of the holding port. Oh my, what's this? Retaining. I think I should just add wall, retaining wall. Okay, gap size. Retaining wall is not port. Okay, this one is to design or modify a retaining wall and also the location for the port. Okay, gap size, right? So all have 5 aspects, so it's quite easy for you all to write. It's already given the aspect. Okay, let's write in the table form. Okay, first, okay, kita tulis balik semua aspek. Location of the port. Okay, what else this one? Design structure of retaining wall. Okay, surface of retaining wall, height of retaining wall and gap. Reka bentuk or design. Design of wall. Then we have surface of retaining wall. Height of retaining wall and gap size. size of gap. Okay. We have 5 only. Okay, location of the port is either you choose bay or cape area. Okay. So normally we choose bay area. Okay. So bay area, this one is less wavy area. Okay. Don't write to prevent erosion because it's already given in the question. You cannot repeat that. Okay. Design of retaining wall should be inclined at the bottom or thicker at the bottom also can, or you can draw something like this. Okay. So incline at the bottom, it will reduce energy or weight, or withstand high high pressure of water. That's okay. Surface of retaining wall is uneven or rough also can. This one also same, to reduce amplitude of wave due to energy loss, because this one is uneven and rough. So reduce amplitude of waves. Height of retaining wall should be high, prevent overflow of strong. Okay, strong wave normally is high, so if too short, the retaining wall, the strong wave also can reach the port. Okay, size of gap must be smaller to increase diffraction effect. Effect of diffraction is more obvious, or the wave will be spread more. Okay. Okay, so this one all for section C. So I think that's all. I've discussed all some of the question, paper 1, paper 2, section B, and section C. Okay. So do you have any question, those online with me? Ada soalan? Siapa yang online dengan saya tu? Ada soalan? Okay, kalau tak ada soalan, saya nak end live. Okay, thank you for joining me. Bye. Okay, bye, Fadlin.